I've got this equation, y equals 3x minus 4, and I see right here, I can start with my y-intercept, because this one is in slope-intercept form. So this is going to have the y-intercept of 0, negative 4. Don't forget, for your y-intercepts, your 0 is always, your x is always 0. And so from the origin, I'll go down 4, because it's a negative 4. That's my y-intercept right there. 0, negative 4. But then I see my coefficient of x, that's going to be my slope, which is, it's showing us 3, but I'm gonna make it fraction so I can see the rise and run. Since my numerator is positive, I know it's gonna be up 3, and then my denominator is also positive, so it will go to the right 1. But it's from that ordered pair we put on the graph, the y-intercept. So I go up 1, 2, 3 to the right 1, that's my next point. Then I just continue this stair-step pattern, up 3 to the right 1, up 3 to the right 1, until I get to the end of my graph. And I can see that I can actually go backwards on this too. So left 1 down 3, left 1 down 3. Okay, so that's all the points that I can fit. And so now I'm ready to put the line on the graph. So something like this. That's it. Now just as a quick reminder, don't forget that all these ordered pairs, all of them, including this one right here, we'll say this one 3, 5. If you were to replace the x with 3 and the y with 5, you would get a true statement in this equal sign, in the equation. Or if you use this point down here, which is at negative 2, negative 10, if you were to replace the x with negative 2, the y with negative 10, you would also still get a true statement. So all the points on the line make the equation a true statement. Okay, with that, here's our 2 objectives for the day. I can graph equations in slope-intercept form, but also some equations won't come in slope-intercept form, so we're going to force them into slope-intercept form using principles of equality. And then, yeah, don't forget we got a mastery quiz next time. So what is the solution? The solution is where you can take the variables in the equation, replace them with numbers, you can get a true statement, just like we would have seen with the bell work. It's just now we're going to start seeing with, it says 2 or more variables, but again, we should only be seeing this with 2 variables for now, which should be x and y. We should be seeing these in as ordered pairs because they go together, right? X and y. So when we replace the x and y in the equation with values, we should get true statements. And the nice thing about that is since there's an infinite number of values that should pair together to make the equal sign true, then we can form a line, which is a nice quick way to show all the infinite values that would make the equation true. So just like we saw last time, slope, it's like a set of stairs like we saw on the bell work. So slope, rise over run. Remember, rise is up and down, run is left and right, but direction is important. So rise, up is positive, down is negative, just like we saw on those number lines. And then run, right is positive, left is negative, okay? We need to remember that because even sometimes when we see a slope that's given, maybe like negative 4/7, okay? I usually like to make my denominator positive, so I'd keep the 7 positive, but the negative I would apply to the 4. And again, if this was my slope, then I'd say I would have to go down 4 and then to the right 7. Because the 7 is positive, the 4 is negative. Okay, so I have to keep that in mind. If you see negative fractions as your slope, it's likely you're going to have to be going down and then to the right. But you could, if you want to, you could reverse this and make the 7 negative and the 4 positive. Then it would be up 4 to the left 7, which is going to have exactly the same steepness. It's still going to create a straight line. It's just, it's going in a different direction. That's it. Then yeah, what we saw with the y-intercept, if you have a line, let's say like this one right here, the y-intercept is where the line goes through the y-axis. So you're just looking at the y-axis, and in this case, the red line, just see where they cross each other. So it looks like it's about right here. I'm going to say this is, it's about at 0.5, so I'm just going to say 0.5. Or you could have it, sometimes it's in the negatives, right? So like this one. And then I look at this green line and say, well, this one is going through the point at 0, -7. And 0, -7 then is the y-intercept, okay? It's a visual check. If they give you a line, it's a visual check to see where it goes or where it is. If they give you an ordered pair, then you just put that point on the graph and then you use the slope to find the rest of the points that are on that line. So those are the two things you need in order to graph an equation. You just need the slope and you need the y-intercept. It says any other point will do. That's for later though, so don't worry about that, okay? So right now we're just focused on slope and y-intercept. Now, last time we saw there was a couple of problems where they actually just said the slope is this number and the y-intercept is this number. If they do, that's fine. But we saw also that it's possible to give the slope and y-intercept in this slope-intercept form equation format. Okay, and so it says y equals mx plus b. They, for some reason, used m as to represent slope, and then the b being the y-intercept. Again, I don't know why they used b, but they did, okay? But these are just locations in the equation, right? So if it takes on this form, y equals mx plus b, whatever number is in this location as the coefficient of x, that is your slope. Whatever number is being added or subtracted here, well, that's your y-intercept. Okay, so they're just locations in this equation. We'll also remember that if it's a minus sign right here, then it makes the y-intercept negative, but also that our y-intercepts should be shown as a ordered pair because it is a location on the graph. It's just your x is always going to be 0. Always 0, okay? And then whatever number's in the box there would be the number that goes here. So all that's review. We saw a problem like this on the bell work. Here's a nice review because again we're seeing the slope here as a negative. But let's take the y-intercept first, okay? Let's get the y-intercept on the graph. And again, this one, don't mistake this for 0, 4. It's got the minus sign in front of it, so it's actually a negative 4. So I go to my origin, right in the middle, and I go down 4, because that would be where the y-axis is negative 4, or the point 0, negative 4. It's the same thing. And then, now that I've got that point on the graph, where do I go? Well, that's what the slope is going to tell me, okay? So my slope here, I'm going to write it as a negative 2 over 5. So the negative 2, that's my rise. That's up and down. Since it's negative, it's going to go down 2. And then the run there, the denominator is positive, so that's going to go to the right 5, okay? So I take that purple ordered pair I put on the graph, the y-intercept, and then I go down 2, 1, 2, and then to the right 5. That's my next point. And then again, I can see I can fit another stair step in there, so down 2 to the right 5. Same exact stair step, right? But since I'm doing this by hand, I'm going to go to the left as well, so I'm going to go left 5 up 2. See how I reversed it now, right? I'm not going down 2, right 5. I'm going left 5 up 2. And then I can fit another one in there. Left 5 up 2. Boom. Okay, so this should be the points that I need to connect now. So let's go and connect those then. And since I'm doing this by hand, I'll put arrows on the end. Of course, on the assignment, I believe you just have to put 2 points on there. And then it will just make the graph for you, which is pretty convenient. But usually the one of them that makes it, one of the points is very easy to put on there just because it's given in the equation, okay? So they're just giving us the information in an equation format, but these are exactly the same amount of information. Lines with 0 slope, these are just flat lines. But we know as well, since they're flat, they're just straight horizontal. And so they take on this format y equals the number, just whatever the y-intercept is. So it's not going to take the form y equals mx plus b. You could, which we saw last time, but I believe on the assignment they just want y equals some number. That would be considered the most simplified format. So 2 things on this. If you see a horizontal line, you're just expecting the equation to be y equals some number. If they give you an equation, like, I'll give you an example here, y equals negative 9, then you're expecting also a horizontal line, okay? So they're going to either do one or the other. They'll give us the graph, then we write the equation, or they give us the equation, then we make the graph. But if it's just y equals a number, it's a flat line, like this one, okay? So y equals 4. So I say, okay, y equals 4, it's a flat line. I know that for sure. But again, where is it a flat line at? It's where y is 4, right? So I go to my y-axis. It's positive 4, so I just find 4. Boom, there it is. And then I know I've got a point there at 0, 4. And this is just going to be a flat horizontal line that goes through this point. Okay, so that's pretty good. Right there, that red line. That's it. Okay, I don't really need the slope because it didn't give me a slope. That means that it has no slope or that it has zero slope. It's a flat line. And then we just need to know where it goes to the y-axis. We found it. So they either give you the equation like they did on the last one or like this one, they just give us the line. So on this one, they've given us a flat line. So once again, I am expecting the equation simply to be y equals some number. So I go down here, I see it's going through the y-axis here at -6. So that means the equation is simply y equals -6, and that's done. Now, if the line has no y-intercept, this means that the line is going to be a vertical line. Okay, that means it's straight up and down. Now again, we saw this last time, and again, they're going to give us this in two ways. They may give us an equation, so like this, if it says x equals just some number, let's say 7, I guess. Then again, we're expecting a vertical line on the x-axis 7, where it's 7 on the x-axis. Okay. On the other hand, if they gave us a graph where it's just a vertical line, then we would know that the equation is going to be x equals whatever the number is on the x number line. That's it. Okay, so these ones, if you see them, you can find the slope, you'll find that the slope is undefined, which if that happens, that is also another clue that your answer or your equation needs to be in the format x equals. So like this one, x equals 9. X equals 9, right? So I say on this one, I know it's going to be a vertical line because it's x equals. Okay, so it's a vertical line where x is 9. So I find 9 on my x number line. There it is. And then I just need a vertical line there. That's it. Okay, so I take my vertical line here. And since I'm doing it by hand, I'll put arrows on the end. That's it. Okay. So that last one gave us the equation, then we graphed it. This one now, it's giving us the graph. We just got to write the equation for it. But again, since it's a vertical line, I'm expecting the equation to be x equals some number. But again, what number is it? Well, I can see it's going through the x value of -7 on that number line. Again, that's as far as we need to go there. Now, if an equation is not in slope-intercept form, it'll be in what we call standard form, if you care. But what we're going to do, just like the objective said, we're going to take the equation and force it to be in slope-intercept form. Okay, so just in case you don't remember, even though we did see it already, y equals mx plus b, where m there is the slope, and then the plus b part of that is the y-intercept. Okay? Because if it's not in this format, it's not giving us this direction, this information directly. But we want to see that information. Those are the two things we need in order to graph the equation. Okay, so we have to be able to change these equations into slope-intercept form using principles of equality, which hopefully you remember means we're just making zeros and ones. So there they are, the principles of equality, which we saw from the first unit. And we saw also in 1.8 that it's possible to start manipulating equations for specific variables, right? On these ones, we're going to be solving for y. But again, just as a reminder, we use addition or subtraction to make zeros. And then we use multiplication or division principles of equality to make ones. And this time, we're going to be making ones for the coefficient of y. And yes, principles of equality are just whatever you do to one side, you must do to the other side as well. And that will not change the equation. It changes the way it looks, but not the overall value of it, okay? So, expect to use these and expect it to be very similar to what we saw in literal equations, 1.8. So like this one, it says just put this equation, just change it into slope-intercept form, all right? So this means that the equation in the end, it needs to be in this format, y equals mx plus b, okay, where m is the slope, and then the plus b here is the y-intercept. This one's not asking us to graph. We're just going to practice first changing the equation into slope-intercept form, and then we'll have other ones that will practice with changing it into slope-intercept form and then graphing. So if I were to look at this one, I know that I would need a principle of equality first to isolate. Again, we're isolating the y. See down here, we're solving for y. So I'm going to take my 8y, and I need to be able to drop it, right? So that it's by itself. So this means that the 12x is in the way. I need to get rid of that 12x. And to do that, I'm going to subtract 12x from both sides. Now, I'm trying to offset this minus 12x here from the negative 26. These are not like terms that I can combine, so I need to keep them separated as negative 12x and then a negative 26. They need to stay separated. They're not like terms that you can combine. But already you start seeing that this equation is pretty close to the format of slope-intercept form. It's just, what's the coefficient of y right here? It's a phantom 1. So I can't have this 8 coefficient there. Now, to change that 8 coefficient into a phantom 1, you could divide both sides by 8, but really what we're going to end up doing is dividing all the terms by 8. So this leaves me with y equals, right, because it's a 1, but I'm going to make it a phantom 1. And then we'll simplify negative 12/8 to negative 3/2. That's how many x's we have. And then the negative 26 divided by 8, that can simplify into negative 13/4. Now again, this one's not asking us to graph, but this is all we need right there, right? We have our slope at negative 3/2, and we have a y-intercept at negative 13/4. So again, we're not graphing this, especially since the y-intercept is a fractional value. So we're not worried about that yet. We will be able to graph them in the future, but just not yet, okay? So I got y equals mx plus b. We've got a slope. We've got a y-intercept, which are the two main things you need in order to graph an equation. So here's an equation, right? 4x plus y equals 7. We want to graph it, but we need to change it into slope-intercept form first. So we're going to use principles of equality there. All right? So I'm going to solve for y, right? So just like we did in that last problem, I'm going to take this stuff here, and it's the 4x I need to get rid of, right? I just need to be able to take that y and drop it. It is by itself, by the way, so I won't need to divide by the coefficient. But I can get rid of that 4x by subtracting 4x. I need it zeroed out. How do I know I need to zero it out? Because it's being added with the y. Anything being added or subtracted needs to be zeroed out. That's what the addition and subtraction principles of equality are for. So that does zero out, just as planned. Now I've got negative 4x. And then that 7, again, I can't combine it with the negative 4x because it is not a like term. So this is my equation. Again, if there was a coefficient of x other than a phantom 1, I'd have to divide all the terms by it, but I don't. I don't have to because it is a phantom 1, okay? So again, let's start with our y-intercept. It's showing us plus 7, so it's going to be 0, 7. So I make this point up here at 0, 7. I'm labeling it 0, 7. And then I have a slope here. It's just showing negative 4. But I'd like to see this as a fraction, so I just make it negative 4 over 1. The negative, that's my rise, and since it's my rise, it's negative, it's going to go down 4. And then my run there is positive, so it's going to go to the right 1. But it's from that ordered pair we put on the graph, because some students are like, well, there's my ordered pair, but I always work from the origin. No. You work from the origin for your y-intercept. The slope is applied from your y-intercept. So I'm going to go down 4, 1, 2, 3, 4, and then to the right 1. There's my next point. Down 4 to the right 1, down 4 to the right 1, down 4 to the right 1. Okay. So this is all the points that I can fit on the graph. Now I'm ready to just draw the line going through the points. There it is. That's good enough, anyways. And that's it. Okay, so are you going to have to change some of these problems into slope-intercept form? Yes, you will. And then also you'll have to graph them. So this one's the same thing. Again, it's kind of close to slope-intercept form, right? Y equals mx plus b. This one, though, it's the negative 2 coefficient of y that's the problem. So I'm going to have to take that negative 2, and I'm going to have to divide it with all the terms. Okay. So negative 2 divided by negative 2, there's the 1, which again, that's going to change the equation into just phantom 1 y equals, and then I got 3 divided by negative 2, which would just show up as negative 3 over 2 x's. And then also we have the negative 4 divided by negative 2, which would be positive 2. Okay, so that slope-intercept form right there, I see that I have my y-intercept, which is at the location 0, 2. So we can put that on the graph from the origin I go up to. That's my ordered pair, 0, 2. And then we have the slope of -3. Again, I'm applying the negative to the numerator. -3 over 2, that's going to be down 3 because it's a negative. And then the 2 is positive, so it's going to go to the right 2. Okay, so from there, I go down 3 to the right 2, down 3 to the right 2, down 3 to the right 2, down 3 to the right 2. Okay, and this is all the ordered pairs that I have. I can also go the other direction, left 2, up 3, left 2, up 3. And that's all the points I can fit. Now that I have those, I'm ready to put the line on the graph. So let's go ahead and get that in there. Something like this. That's it. So graphing on the assignment, sometimes it'll be fairly simple, like the ones we just saw. You just click on 2 points, and then it puts the graph on there for you. But it's going to try to make you do it what feels like it's done by hand. So first, of course, you're going to have to change the equation to slope-intercept form. After you do that, you put 2 points on the graph, and then what's going to happen, it's going to say, are you done plotting points? You can do more than 2 points, by the way. But after that, you click on done plotting points, and then you draw the line along the ruler. It's going to put a ruler on the screen for you. You got to draw the line, a full line on there, all the way across until it gets to the both ends. If you make any errors, you're going to have to undo your line and just start your drawing over. Not the points, just the drawing. And then after that, you just click on Submit Answer. So on this one, here we got the equation 3x equals -6y plus 12, following the instructions below. So it says, well, put some points on the graph. Okay. But before I do that, I'm going to take this equation and I'm going to change it in the slope-intercept form, right? Now, my slope-intercept form this time, since my y is on the right side there, I'm going to make it y equals like this, mx plus b. And some students get a little baffled by this, but it's okay to do that, by the way. So start out up here, okay? I got my 3x, but it equals -6y plus 12. It's the plus 12 that's interfering with my y's right there. So I'm going to I want to be able to take my -6y's and just isolate them. I want them by themselves. So I don't want that plus 12 there. So I'm going to have to subtract 12, not only from one side, but from both sides, okay? So that will zero those out just as we planned. Now I have, again, I can't combine those two terms because they're not like terms. So I got 3x and then -12, okay? I'm close, just not quite there. Last thing I need on this one is to divide all the terms by the coefficient of y, which is -6, okay? So this ends up being 3 divided by -6 would be -1 over 2 x's. And then -12 divided by -6 is going to be +2. And then this equals phantom 1y. Okay, so this is in slope-intercept form. If that really bothers you having the y on the right side, just switch it over here and that's fine as well, okay? But from this, I now have my y-intercept, which is what I need. It's one of the points I need. That's going to be at 0, 2. So from the origin, I go up 2. And then I use my slope, -1 over 2, to find my other points. Okay, so this is my slope, which is -1 over 2. My 1 is negative, so that's going to be down 1. And then the 2 is positive, so that goes to the right 2. Okay, from that point, so I go down 1 to the right, down 1 to the right 2, which is this point. And then you'll see something like this. They're going to put the ruler on the graph, and at this point, so after, of course that's after you submit it, but you got to draw a line, not just between the 2 points. So if you drew a line just like right there, it's not going to give you credit. Okay, so don't just do it right there. But if you take your mouse and just kind of slide it along this line, just as long as it's close, it'll give you a straight line, and it'll be pretty. But you need to do that until it shows arrows on both ends. If you don't do that, it's not going to give you full credit for it, okay? Once you do that, and then you draw the line, so again, you just take your time to draw those lines, but once it shows with arrows, then you're good to submit that. Yeah, so it needs to look something like this right here. And that's it. So hopefully you feel pretty good about graphing equations in slope-intercept form. And then also, you need to be able to force the equations into slope-intercept form, no matter what format they're in. And then yes, please don't forget, at the beginning of class next time, we'll have a quick review, and then the mastery quiz, which is on this stuff, okay?